Okay, here is the next video reviewing the quizzes. So here I'm going through quiz number 9. A capacitive reactance of an element is 50 ohm. What will be the value of capacitance if omega is 100 radian per second? So basically he gave us XC equal to 50 ohm. XC is nothing but 1 over omega C. He gave you omega values, so he's asking about C value. C equal to 1 over 50 times 100, so it's 1 over 5,000. So can I put that as 10 to the power of negative 3 over 5? 1 over 5 is nothing but 0.2, so 0.2 millifarad. Now what is the resonant frequency of RLC parallel circuit? So for RLC parallel circuit or series circuit F0, that resonant frequency is nothing but 1 over 2 pi square root of LC. So 1 over 2 pi square root of L is 2 milli and C is 2 milli. So it's a square root, so 2 milli square root get cancelled. So 2 pi times 2 milli, we'll end up with 1000 over 4 pi. What is that value? That value is 79.57 hertz. 79.57 hertz. Now he gave you Z1 in impedance, Z2 impedance. He's asking about Z1 over Z2. So Z1 equal to 6 plus J8. I can write this as 10 at an angle of tan inverse of 8 over 6, which is 53.83. Okay, and Z2 is 4 minus J5, which equal to 5 at an angle of 4 minus J3, 5 at an angle of, this is minus 36.86. so 10 over 5, which is 2, and you're going to subtract the angles. 53.83 minus 36.86, so we'll end up with, that's 90 degrees, 2 at an angle of positive 90. So C is the right answer. I1 equal to 5 at an angle of 30 and V1 equal to 550 at an angle of minus 30. So if I draw the vector diagram, here is my I1, 5 at an angle of positive 30, and V1 is 50 at an angle of negative 30. So here, so stand at one point, rotate the vectors. You don't move, rotate the vectors. So I can say voltage lagging current by 60 degrees. This is a true statement. Voltage is behind the current after 60 degrees, or you can say current is leading voltage by 60 degrees. I can say current is in front of the voltage, 60 degrees in front of the voltage. So that's also a true statement. Or current lagging voltage by 300 degrees. If you stand here, okay, voltage is coming first, then after 300 degrees current is coming. So this statement is also true. All three statements are true, but we always use this statement because we always take voltage as a reference and current leading voltage by 60 degrees. All three statements are true, all three statements are correct, but this is the appropriate statement. So the right answer is all the above statements are correct. Okay, but this is more appropriate statement. Okay, now a 20 ohm resistor connected in series with 0.125 farad capacitor. What is the current flowing in that circuit if the supply voltage is 100 volts? So you have a 20 ohm, so XC minus JXC equal to minus J over omega is 1, C is 0.125. I believe that's 1 over 8, so I can write this as minus J8. Now this is giving a supply voltage of 100 volt. Okay, so what is the current? I equal to 100 over 20 minus J8. So convert that into polar form. So after doing the calculations, I end up with I equal to 4.64 at an angle of 21.8, or Z equal to 20 minus J8. It is 21.54 minus 21.8. So 100 over 21.54 is 4.64, and the angle when it goes to the numerator, it is 21.8. So when I convert that into polar format, sorry, this is polar format. When I convert that into rectangular format, it is 4.3 plus j 1.72. That's the right answer. Now, next question. What is the equation for magnetism of the Gauss's law? So when it comes to the Gauss's law for the magnetism, B times dA closed integral equal to 0. Next question. Which of the following statement is true regarding the electromagnetic wave? Electromagnetic wave carry energy. That is a true statement. Electromagnetic wave or transverse waves. That is a true statement. Electromagnetic wave travel at the speed of light. That's also true statement. So all of the above are true statements. If the amplitude of magnetic field of an electromagnetic wave is 2.5 times 10 to the power of minus 7 Tesla, what is the amplitude of the electric field? So C equal to E naught over B naught. Amplitude is nothing but the maximum value. It is also E over B, RMS value. You can use the RMS value. You can see here I used this formula basically. Speed of light C equal to E over B. So he gave you B value. He's asking about E value. E equal to 3 times 10 to the power of 8 times 2.5 times 10 to the power of negative 7. So what is that value? 3 times 2.5, is it a 7.5? So 75. Okay. At point X, a charged particle has a kinetic energy of 9 microjoules. It follows the path shown from X to Y through a region in which there is an electric field and magnetic field. At Y, the particle has a kinetic energy of 11 microjoules. At Y, the particle has a kinetic energy of 11 microjoules. What is the work done by the magnetic field on the particle? So even I got confused on this question. So he's talking about work done by the magnetic field. Okay. So if a particle is moving from X to Y, there is a work done by the electric field. That work done is nothing but, so if you remember potential difference, VAB equal to negative work done over Q. Okay, so VAB is nothing but VA minus VB. VAB, I can write this as E over D. Okay, so work done is nothing but E times Q over D. Okay, so there is work done by the electric field but not by the magnetic field. So work done by the magnetic field is 0 microjoules. Even I got confused and I tried to solve it by using this. I tried to find the electric field. I was thinking about 2 microjoules, but no, he was talking about the magnetic field. Okay, now last one. Which of the following best describes the difference between the radio waves and X-ray waves? X-ray waves and radiation waves. X-ray or radiation, while radio waves are electromagnetic waves. Both of them are electromagnetic waves. That's a false statement. Both can be thought of electromagnetic waves. They differ in wavelength and frequency. Yeah, both of them are electromagnetic waves, but they differ in the wavelength and frequency. X-rays are pure energy. Radio waves are, both of them have energy. Radio waves come from electric currents in an antenna. X-rays are not related to electric charge. No, that's not true. So B is the true statement. Okay, looks like I made a mistake in the previous video regarding this first question. So here is the trajectory path. So which one is the right answer? Let me erase my old answer. So here it is. So basically, which one is the right answer? So here, for sure, electric field. So if you look at here, electric field always starts from the positive charge. So here we have positive charge and here we have negative charge. Okay, so I think I chose this as an answer, but in real answer is this. I will explain why is that. Here initially the charge is basically initially it has some initial velocity. Okay, initial velocity, and we are shooting this charge with an angle theta. If it doesn't have any initial velocity, what happens? It automatically moves towards the negative charge. But we gave some initial velocity with some angle theta, so basically what happens, it will travel with that angle, but at the same time, same charges oppose, opposite charges repel. Sorry, same charges oppose and opposite charges attracts, so it will go towards down because same charges will repel. Okay, that's how the path is going to be. So this is the right answer. In the previous video I chose this as the right answer, so please ignore that. Thank you. Looks like I also asked different questions in the quizzes what I showed in the previous videos. So I will go over some of those. So two very long parallel wires carry equal current in the same direction into the page as shown in figure. At point P, which is 10 centimeters from each wire, the magnetic field direction is, he's talking about, let me write it down in another page. So here is a question. You have two currents going into the board. He's talking about what is the magnetic field at point P. So current is going into the board. So according to the right hand rule, thumb indicates the magnetic field direction and folding fingers indicates the thumb indicates the current direction, folding fingers indicates the magnetic field direction. So if I take this as 1, this as a 2, take this as 2. So because of 1, thumb indicates the current direction, folding fingers indicates the magnetic field direction. That's the magnetic field direction. So at point P, because of this, it's going to be something like this, B1. Okay, now same thing here, because of this it's going to be in this direction, so it's going to be B2. So what will be the resultant magnetic field direction? It's going to be in this direction, which is towards right. So the right answer is directed to the right. Now the next question I want to go over, here it is. Here I showed you it's basically a electrical motor. Okay, you have north pole and south pole and a field coil. Which direction the coil is going to rotate in the above given simulation diagram? Okay. So clockwise direction or anti-clockwise direction, it will not rotate. So for this, I think I can write here. So for this, you have a north pole and south pole. So that's the magnetic field direction. Okay, that's P. And here is a coil. So in this coil, I said current is going up. Here our current is coming down. Because basically this is connected to through a slip rings or commutator to a battery in that direction. I will show you one more time the diagrams. So you can see the simulation diagram here clearly. So the current is going in on the left hand side, current is coming out in the right hand side. Here I'm going to use the right hand rule. So thumb indicates the force. So if you place your right hand 3 fingers perpendicular to each other, so your middle finger indicates towards right and forefinger away from your face. So you can see the direction of the thumb direction is towards down, so it's going to rotate in anti-clockwise direction. So I'm going to stop this here. If your time permits, please go through this video before taking the quiz. Thank you.